This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today we're diving into the world of amateur radio antennas, a topic that can be both fascinating and frustrating for hobbyists. Our guest is an expert in this field and will be exploring practical antenna designs and construction techniques.
The key is understanding the fundamentals. Many amateur radio operators struggle with antenna design because they get bogged down in complex theory. Simplicity and effectiveness are often best.
Exactly. Many designs are surprisingly straightforward. Let's start with the basics. What exactly defines an antenna?
At its core, an antenna is a transducer, converting electrical energy into radio waves and vice versa. It's all about efficient energy transfer.
And that efficiency is key to achieving good communication range, right? So you mentioned the antenna as a transducer. Can you elaborate on that definition and perhaps give some examples of different types of antennas?
Certainly. The ARRL defines an antenna as a transducer, converting radio frequency electric current into electromagnetic waves. Think of a half-wave dipole, a very common and effective design. It's resonant at a specific frequency, meaning it's most efficient at that frequency. Then there are non-resonant antennas, like the random wire, which can operate across multiple bands but require an antenna tuner.
Let's focus on resonant antennas. The half-wave dipole is a classic example. How do we determine the correct length for a dipole antenna for a specific frequency?
The simple formula, 492 of MHz, gives you the length in feet for a half-wave dipole. However, this is an idealized calculation. The actual resonant frequency is affected by factors like wire diameter, insulation, and even the surrounding environment. It's often necessary to fine-tune the length after construction.
Now let's shift to non-resonant antennas. You mentioned the universal antenna and the G5RV. What makes them different from resonant antennas?
Non-resonant antennas, like the universal antenna and the G5RV, operate across a wider range of frequencies. They don't have a single resonant frequency. This versatility comes at the cost of requiring an antenna tuner to match the impedance to your transceiver. The G5RV, for example, is a popular multi-band antenna known for its relatively simple design.
And what about the random wire antenna? Is it as random as the name suggests?
The term random is a bit misleading. While it doesn't have a specific length determined by a formula, its length should be chosen to avoid resonance on your operating bands. A well-designed random wire antenna, often used with a tuner, can be surprisingly effective.
An important distinction is between balanced and unbalanced antennas. What's the difference and why does it matter?
A balanced antenna has equal currents flowing in opposite directions on each leg. An unbalanced antenna, like one fed with coaxial cable, has current flowing on the shield as well. Using a balloon helps convert between balanced and unbalanced systems, minimizing current flow on the coax shield and improving radiation efficiency.
Antenna directivity is another key concept. Can you explain what it means and how it relates to antenna gain?
Directivity refers to an antenna's tendency to radiate more strongly in certain directions than others. Antennas with high directivity, like beam antennas, concentrate their power in a specific direction, resulting in higher gain. This means they can achieve better communication range in that direction.
Antenna tuners, or couplers, are essential for many antenna systems. What role do they play?
Antenna tuners match the impedance of the antenna to the transceiver, ensuring efficient power transfer. They're crucial for non-resonant antennas and for optimizing performance with various antenna types. Both manual and automatic tuners are available, each with its own advantages and disadvantages. Building your own tuner can be a rewarding project.
Polarization is another factor to consider. How does it affect radio communication?
The polarization of a radio wave refers to the orientation of its electric field. Horizontal and vertical polarizations are common. Matching the polarization of your transmitting and receiving antennas is important for optimal signal reception. The importance of polarization varies depending on the frequency band.
Let's talk about practical construction techniques. What are some tips for building effective antennas?
Careful planning and execution are key. Using quality materials and proper construction techniques are essential for a durable and efficient antenna. Crimping connectors is often preferred over soldering for antenna wire joints, as it provides a more robust connection. And always use insulated wire, especially in coastal environments.
Can you give us some specific examples of simple and effective antenna designs that amateur radio operators can build?
The half-wave dipole is a great starting point. It's easy to construct and provides good performance. For multi-band operation, the G5RV is a popular choice. Even a simple random wire antenna used with a tuner can be surprisingly effective for a home station.
What are some common problems amateur radio operators encounter when building or using antennas, and how can they be addressed?
Poor impedance matching is a frequent issue, leading to reduced efficiency and high SWR. This is where an antenna tuner becomes invaluable. Another common problem is improper construction, leading to poor connections or damaged components. Careful attention to detail during construction is crucial. Environmental factors, such as nearby metal objects, can also affect antenna performance.
Where can amateur radio operators find more information and resources on antenna design and construction?
There are numerous books and online resources available. The ARRL Antenna Book is a classic reference. Online forums and communities provide a wealth of information and support. Experimentation and learning from others' experiences are also invaluable.
So to summarize, building effective antennas for amateur radio involves understanding the fundamentals of antenna theory, choosing the right design for your needs, and paying attention to construction details. Simplicity and effectiveness often go hand in hand.
Precisely. Don't be afraid to experiment and learn from your mistakes. There's a lot of satisfaction in building your own antenna and seeing it work.
That was great discussion. Thank you for sharing your expertise.